Welcome back to finding the points on a unit circle. We have been talking about this unit circle all week long. Today, we're going to finish this thing, and we're going to find out how to do the coordinates of this. In the other videos, we've been talking about the inside of this unit circle with these degrees and the radian measures, which I have blanked out for demonstration purposes. I can't show you that real fast. This would be what the radian measures are. We just reviewed that in class. I'm going to take that back off and show you how to find these things here. All right. Get this on here. First thing I'm going to do is, starting right here, I'm going to drop a line straight down here, making a right angle. And I'm going to go ahead and just trace this 30-degree thing like this, thus making a right angle right there. All right. Now, the only thing that we know measurement-wise on this unit circle is how long the, what makes a unit circle is how long the radius is. And that means from here up to this coordinate here, and by the way, these things right here are the coordinates of this unit circle. But the only thing I know is how long that radius is, which means I know that the hypotenuse is 1. Now, let me fade the unit circle off, and we'll get rid of that right there. Oh, that's on the other one. Never mind that. All right, this angle was equal to 30 degrees. That was equal to 30 degrees. If I bring that back up just a second, you can see that it's the 30-degree thing. What I'm going to do now is show you how to find these two sides, because once you understand that, you can fill out the entire unit circle. There's a trick rule you have to know, and that is the side opposite a 30-degree angle. The 30 is half of the hypotenuse. A side opposite the 30-degree angle is half of the hypotenuse. The hypotenuse is 1, so the side opposite the 30 is this one. That makes this equal to 1/2. 1/2. And due to Pythagorean theorem, which is a squared plus b squared equals c squared, if I call the hypotenuse c, which I should always do, I'll go ahead and call this a and this b. And if I solve this for a, I'm going to get that thing that has the radical 3 and the 2 in it. So let me show you how that all works so that you can do it yourself. I am against memorizing this. You can figure this out on your own. We don't know a. I'm going to pick up the pace here, bring in b, which is a half, and that gets squared, just like Pythagorean theorem, straight out of 9th grade math. C is 1, so that's 1 squared. There it is plugged in. Now we're going to simplify. A squared plus 1/2 squared is 1/4 equals 1 times 1, which is 1. Now remember, our goal here is to get a by itself, so we subtract the 1/4. So that's a squared equals, now what's 1 minus 1/4? Anybody? 3/4. Good. Now, if we solve this for a, we have to square root both sides. So I'm going to square root a squared and square root this entire fraction. And this is where people usually fall apart. But the square root of 3/4 is just the square root of 3 over the square root of 4. That's a rule of algebra 2 right there. We simplify if possible at this point. The square root of 3 does not simplify. The square root of 4 is 2. So that actually is good to go right there. We don't have any more shenanigans to do with that. We can call a equal to the square root of 3 over 2. So the last thing we have to do is figure out what the coordinates of this point is. Well, points are always of the form x, y. This is the x direction here, the sideways. The y direction's up and down. So which one would go in here? The 1/2 or the radical 3 over 2? The radical 3 over 2. The 1/2 would go here because that's the y direction. This is x, y. And if we fade the unit circle back on, you can see that this is radical 3 over 2 and 1/2. Radical 3 over 2 and 1/2. Very cool. Now, to get this one, which I also would like to do here really fast, and we'll go even faster on this one, is if I go up to the 45, sorry about that. If I go up to the 45, down, over, tracing my isosceles right triangle there, this is going to be a 45-degree angle here. I'll fade the background off that now. We still know that the hypotenuse is 1. And this here is going to be A. Now, normally we would want to call this B. But since it's going to be the same, because if this is 45, that means this is 45. And therefore, the two sides are the same. We call this A. So it's A squared plus A squared equals C squared. So when you're doing an isosceles right triangle, which you rarely do, but in this case we have to, we call it this. The only thing we know is C, so we plug in 1 for C right there. So it's going to be A squared plus A squared equals 1 squared. Okay, now I asked the other class this and they missed it. I'll ask you guys. A squared plus A squared, what is that? 2A squared. Good, even though I heard some wrong answers. 1 squared is 1. All right, now we're going to solve for A squared. This is algebra kung fu. Do not let this problem beat you up. We're dividing. We're going to divide by 2. So we got A squared equals a half. What now? Square root. This one's going to be a little bit more messy. This is A. And this is the square root of 1 over the square root of 2. And then we try to simplify that. Okay, now I ask you, what is the square root of 1? 1, because 1 times 1 is 1. The square root of 2 is just the square root of 2, and we can't leave radicals on the bottom. So what we have to do now is multiply the top and bottom by this radical 2. And what we'll get for our final answer is 1 times radical 2, which is radical 2, and right? Radical 2 times radical 2 is 2. Circle around that. That gets put over here. Radical 2 over radical 2. You can put that in here for both of these. And when you fade this back on the unit circle, we can see that radical 2 over radical 2 over 2 for both of them, as we have here. Radical 2 for both of them. The only thing that you have to do as far as when you look around the circle, and that's going to be a subject for the final video on the unit circle, is you got to realize that there's a pattern here as well, because it's just all about these quadrants that has to do with the signs being negative. You can see that for all 45s, if I just circle this real fast, they're all radical 2 over 2. Every single pink circle I just put on there is radical 2 over 2 for the x and y. The only difference is the signs change depending on what quadrant you're in. Like I said, that's going to be the subject for the next one. I hope you understood this. You really should go back and know how to do this. This is a skill that you should know how to do. I will talk to you later.